Hello everyone, I am Rajdeep Singh from SIRT Excellence, and in this lecture we are going to see the concept of finite state machine. In previous lecture we studied about terminologies and introduction of this subject, theory of computation. Now we are starting with the first topic, that is finite state machines. So let us start with this topic. What is finite state machine? Actually, the formal definition of a finite state machine. So finite state machine can be defined with 5 tuples, and those 5 tuples are q, sigma, del, q naught, f. What are these 5 symbols? Let me explain one by one. First of all, capital Q is written here. M denotes the name of machine. So this is nothing but just the name of machine. You can write anything here. Now tuples, conventionally we write these tuple like it is there. We do not change its name, but again it is not compulsory also, but conventionally we are using the names of these tuples like this only. So if whenever you write in this same manner only whenever you define your finite state machine. So 5 tuples are capital Q. What is capital Q? Written here, Q is the set of states, more specifically finite set of states. Okay, then another one is sigma. I've discussed this term in last lecture also. It is set of input alphabets. Whatever input alphabets you are using in your language, those input alphabets will be denoted by this symbol, which is known as sigma here, which seems as similar as summation, which you have studied in mathematics. Third tuple is del. Now what is del? Del is transition function. What is transition function? So if I define transition function, it is a function which denotes or which describes the pattern of movement in a machine. What is the pattern of movement from one state to another is being denoted by this tuple, which is known as del, or which is known as transition function. Fourth tuple, that is q naught or q0, is called as initial state. Remember, there will only be one initial state in any finite state machine. More than one initial state is not possible. So there will only be one initial state, and that initial state is not some special state drawn for machine. That is among these all these states which are denoted by capital Q. So what is Q naught? Q naught is an element which belongs to set Q. One state is denoted as initial state. And last tuple is F, which is set of final states. I have written here states. That means more than one final state can exist in a machine. One more thing, F is subset of Q. So this is the parent set. Okay, Q is the parent set. Capital Q is the parent set of states. Few state will be termed as final states. One state will be termed as initial state, and other remaining states will be some intermediate states. Okay, normal states. So one more thing with F is there. F will not never be equal to phi. That means final state in any finite state machine can never be a null set. Set of final state can never be a null set. Means हर मशीन में, हर फाइनाइट स्टेट मशीन में एक फाइनल स्टेट कम से कम तो होगी ही होगी. Okay, so this is the formal definition of finite state machine. Now if I talk about classification, so classification of finite state machine is being done as shown here by this hierarchical structure. FSM here stands for finite state machine. Finite state machine, as I told you in earlier lecture also, that it is classified into two branches. First one is finite state machine with output. Okay, that means you are giving something in input and you are getting some string, some, you are giving some string as input and you are getting some string only as output. Okay, so those machine are called as finite state machine with output. Now, another classification is finite state machine without output. Without output doesn't mean that it is not giving output at all. It is giving binary output. What is binary output? Binary output means something two valued. Means either it is giving output in form of 0 and 1. 0 means, let's say, string is invalid. 1 means string is valid. Actually, we are using this type of machine for checking the validity of strings mainly. Now, if I classify these machines further, so finite state machine with output is classified into two categories, that is Mealy machine and Murray machine. These are named on the name of scientist. Now, this Mealy machine and Murray machine comes under the category of finite state machine with output. That means it is taking some string as input and giving some string only as output. And if I classify this category, that is finite state machine without output, it is categorized or it is classified into three categories, that is DFA, NFA, and NFA with epsilon move. I hope you are familiar with epsilon. I have denoted this term in our last lecture. Epsilon means null string. So what is DFA, what is NFA? I will explain it later. For now, for just now, you just take its full form. DFA stands for deterministic finite automata and NFA stands for non-deterministic finite automata. Now, something is written down here. What is it? This is the application where these machines are used. So the green portion or the green classification of the finite state machine is mainly used in digital circuit design. So we are not getting very much deeper into this concept. We'll learn how to make those machines and how to convert those machines. Okay, now this blue side of this categorization or classification has its application in compiler design. So being a computer science student, you have to study it in deep. Okay, so this is about classification of finite state machine. I hope you got this concept. Now let us take an example of how finite state machine is designed. So I'm just giving an example with a sample language set L. Now what is L? L is a language which is consisting three strings, let's say 0, 0, 1 and 0, 1, 1. Now what is happening here? This is a finite set obviously because only three strings are here. There are infinite sets also. So we have to design a finite state machine which says valid for if these three strings come as input, and if anything else comes as input to this machine, it says invalid. Okay, so how we'll construct this machine? So we just consider the first valid string of this language, that is 0. It is written here at first place. 0 is the first valid string. So how does our finite state machine says that string is valid, and how does it say that string is invalid? So the concept concept by which finite state machine is saying a string as valid and invalid is that whenever you read the complete string, at the end, where is your control? If it that control is at a non-final state, then it will be an invalid string. And if after reading the whole string your control is at final state, then we will say that that is a valid string. So what is non-final state, what is final state? So you can see here, whenever we draw a state with a single circle, then it is a non-final state. Okay. And whenever we draw it with double circle, concentric circle, like B is written here, then it will be said as final state. So whenever after reading that string we reaches to final state, it will be telling us that that string is valid. So coming back to our question, we have first valid string as 0. So what should happen after taking 0? Our machine's control should reach to the final state. So and one more thing, how initial state is made. Initial state is made by a single circle with an arrow coming from nowhere. Means you can see that this arrow is coming from nowhere. So this is initial state. That means whenever machine starts, the control should start from initial state, that is state A. Now we are supplying it 0 as input alphabet. So whenever A is getting 0 as input alphabet, it should reach final state, then only it will be a valid string, right? So we have supplied 0 input alphabet to our state A, and it reaches to final state. Look, we are the designer of this machine, so as per requirement we are designing the machine. Here 0 is our valid string, so for 0 we are moving the control to final state. Okay, so it has reached to a final state which we have named as B. Okay, now what happens further? Now what is the second string? Second string in this language set. So second string in this language set is 0 1. Okay, so how will we make it accept that? So it has already taken a 0. If we make a transition with one input, so 0 and 1, after taking 0 and 1, where it is reaching? It is reaching to one another final state that is named as C. I have said that machine can have more than one final states in it. So here we have made a final state which is named as C. So after taking 0, it is reaching to a final state, and after taking 0 1, it is reaching to a final state. What is happening here? Whenever machine start, the control is in initial state, that is A. We have supplied 0 to it, it is reaching to a final state B. If user supplied 0 1, after reading 0 it is reaching to B, and after reading 1 after that 0 1, it is reaching to C. After reading the complete string, you will tell that whether the string is valid or not. If string is not read completely, you cannot say that string is valid or invalid, because you haven't read the string completely. So after reading 0 1, what is happening? It is reaching to a final state which we have termed as C. So done, this thing is also done. Now what is the third string? 0 1 1. Okay, now we have considered this third string 0 1 1, and what will we do? We will just made another transition with 1, and it will reach to one another final state named as D. So what is happening? If the third user, if an end user supplies 0 to this machine, what will happen? It will reach to final state, and this machine will signal yes, it is valid string. If an end user supplies 0 1 to this, what will happen? Yes, it will take 0 and then 1, and what happened? It reaches to C. So this machine, this machine will say? Yes, it is a valid string. What will happen in case of 0 1 1? It will take 0, reaches to B, it will take 1, reaches to C, it will take 1, reaches to D. What will this machine say? It is a final state, D is a final state. It will say yes, it is a valid string. So I think this machine is complete now. Before saying yes, this machine is complete, we'll check कहीं ऐसा तो नहीं है कि ये मशीन कोई गलत स्ट्रिंग एक्सेप्ट कर रही हो. Is there any wrong string which is being accepted by this machine? We have to make a check. So let us say a random check. You cannot check for all the wrong strings, obviously, but you can make a random check to get satisfied that yes, this machine is completed. So let us say we take a wrong string 101. 101 is not present here. So what happens if our control, when our machine start, our control comes to A. So 1, no, there is no transition of 1 from A. Where what will happen? Nothing. It will not move forward. But then question arises, one question can arise, that if there is no transition from A and we cannot move further, so how can, and we have not read that string 101 completely, how can we say that string is valid or invalid? There is answer to that. We'll study a topic by the name dummy states. That state, that concept will clear your doubt that, yeah, how such wrong strings are handled. Okay, let's say 010. No, 010 also will not be accepted in this machine. Why? Because 0 liya to hum B pe aaye, 1 liya to hum C pe aaye. Now there is no zero transition from C, so it is an invalid string. But then again someone will ask, no, there is no transition of 0 from there, that means we haven't read that string completely, so how can we say that string is invalid? So again, my friend, there is a concept of dummy state we'll study in further lectures. So for just for now, from the perspective of making first finite state machine, this is your machine and this is how you have to complete it. Okay, if I say about 5 tuples which we have learned in lecture, in this lecture, what are those 5 tuples? So what is q? Q is set of states. So here what are the states? A, B, C and D. We have written it here in curly braces in the form of set. What is sigma? Sigma is set of input alphabets. So see here, whatever symbol is written here over these arrows is known as transition or known as input alphabets. So these input alphabets are 0 and 1 only. So we have written it here in curly braces in the form of set. Now talking about transition function, I have written here as q cross sigma maps to q, but for now I will not explain what is this because I haven't gone into categorization of finite state machine. I'm just teaching you how to make finite state machine. About transition functions, how it is written, what, how this function is designed, I will teach you in next lecture. For now, just remember that this is a transition function. Now q naught, q naught is initial state. So here in our case initial state is A because इसमें एक arrow बना है which is coming from nowhere. Now talking about last tuple, that is F. F is set of final states. So all concentric circles, double layered circle are known as final state. So here B, C and D are final state. So we have made our first finite state machine. Okay, we'll move on